Hello, welcome to this video on transformations of rational functions. What we're going to go ahead and do is look at various forms of rational functions and then tap into your previous knowledge on transformations that you've looked at with quadratics, general polynomials, and other types of functions to go ahead and transform rational functions. All right, so let's go ahead and first of all define a rational function and kind of what it looks like algebraically. A rational function is a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomials. So if you have a polynomial divided by another polynomial, then you have a rational function. And here are some examples of rational functions. F of x equals 5 over x minus 2. That is a rational function because I have a polynomial in the denominator, right? I have a variable there. G of x equals x plus 3 over x plus 1. Yep, I have polynomials in both of those cases. Okay, and then h of x equals 2 times 2 over x plus 3 minus 4. And that is the kind of form that we're going to look at today. Just also, I want you to remember that an asymptote was defined here, and that is a line in which the function gets really, really close to, but will never, ever touch. And remember, visually, it is defined as a dashed line. Okay, so let's go ahead and check out the general form of a rational function. So here, compared to the parent function, and I would really like it if you would go ahead and make a note. Parent function, f of x equals 1 over x. That's the basic foundational form of a rational function. And what we're going to do today is we're going to look at a transformed rational function in this format. G of x equals a times 1 over b times x minus h plus k. And generally, you won't see a and 1 over b in the same type of problem or the same type of function. You'll either get one or the other. And I kind of want to just go over these for a bit. I'll start off with a, okay, and that's your coefficient or multiplier out front. Okay, and remember, those control vertical stretch, vertical compression, and reflection. If my a value is bigger than 1, the absolute value of it, then I'm going to have stretch. Okay, if the absolute value of a is less than 1, between 0 and 1, then I'm going to get compression. My graph's going to squeeze. Okay, if I have an a value that's negative, what's going to happen is it's going to go ahead and flip. Okay, and next, we'll talk about the 1 over b value. So this is horizontal stretch. Same idea, right? If my b value is bigger than 1, then we're going to get stretch. If my b value is less than 1, we're going to get horizontal compression. And if b is negative or less than 0, then we're going to get a horizontal reflection. Now, here's the catch. B isn't present in the function. It's 1 over b. So what we have to do is we have to go ahead and take the reciprocal of whatever value is visually present, okay? And that's just kind of a quick little, skill that we have to apply. Okay, all right, next, let's talk about translations, moving left, right, up, or down. Okay, so in order to move left or right, that's going to be affected by our h value, And it's important to remember that the h value is always the opposite. So again, what you see, you have to take the opposite, okay? And that'll control left or right. If it's negative, we're going to the left. If it's positive, we're going to the right. All right, our k value, last but not least, that's going to go ahead and move us up and down, okay? If our k value on the end is positive, we're going up. If it's negative, we're going down, okay? Plain and simple. Okay, so let's go ahead and apply some of these. And the first step that I think you guys should do is go ahead and label these transformations, okay? So here the example says, identify the transformations of f of x equals 1 over x that have taken place to create g of x. So here's g of x, and what we have here is a k value, right? That's tacked on at the end, okay? So k is equal to 4. All right, so what does that mean? Well, that means a translation up 4 units. Very, very simple, right? Okay, next, I have g of x equals 5 times 1 over x. All right, this is an a value here, an a value. Okay, so first of all, it's important to note that a is equal to 5, which is greater than 0. So that means we are not going to have any reflection, so no horizontal reflection. And then the absolute value of 5 is greater than 1, right? It's bigger than 1. So that means we are going to have vertical stretch. All right, so kind of how we'll summarize this is we'll say the transformation is a vertical stretch by a factor, because that's important. We want to know how much we're stretching it by a factor of 5. All right. Next, we have g of x, and let me find pink or purple. I think purple's okay. All right, so for this one, we have g of x equals 1 over x plus 3. Okay, so here is the plus 3, but remember that our h value is the opposite. So I have to take the opposite of this. Thus, h is equal to negative 3. Okay, so remember the h value controls if I go left or right. And if you ever get confused, just go back to this sheet, right? And then you can identify, okay, this is an a value. All right, here, this is an h value. What does it do? All right. So h is equal to negative 3, so that means we are going to have a translation left 3 units. Muy fácil, right? Very easy. Oh, I don't want to cut off my 3 there. Okay. And I like to box these just for something us mathematicians do, right? Oh, here's the answer. Let me box it. All right, 3 more examples. Okay, so next, we have g of x is equal to 1 over 0.1x. All right, so here is a 1 over b value. It is 0.1. So 1 over b is equal to 1/10. You agree that's 1/10? Okay, so I'm going to write it as 1/10, and it'll make it very, very simple when I want to go ahead and I want to say, okay, well, what is b? So all we do is take the reciprocal, right? If I have 1 over b is equal to 1/10, well, if I take the reciprocal of both of them, then b is equal to 10. Very, very simple, okay? And it's important to note that b is equal to 10, which is greater than 0. So we're going to have no reflection. Okay, and thus the absolute value of b is greater than 1, right? So this means horizontal stretch. All right, so what is our conclusion? We can say a horizontal stretch by, whoo, that's a weird y, by a factor of 10. How much are we stretching? By 10. Okay, next, moving right along. G of x equals 1 over x minus 7. Hey, this is a k value, super easy. Translation up, not up, down 7 units. That's what I get for not writing out k equals negative 7. K equals negative 7. It's down. All right. Whoop. And box your answer, Schwarberg. So sorry. So sorry. There you go. All right. Next. G of x equals 1 over x minus 8. Hey, this is an h value, which is opposite. So h is equal to positive 8. Okay. Translation right? 8 units. How much? 8 units. Yippee skippy. Very, very easy. Okay. All right. Here are some practice. I lied. Why are you lying, Schwarberg? I didn't mean to. I thought they were practice problems. All right, this is an A value. Okay, A is equal to negative 0.1. It's negative. Negative. It is less than 0. So that means we are going to have x-axis reflection. Okay, and then the absolute value of negative 0.1, which is positive 0.1, that is also less than 1. So this is going to be vertical compression. Okay, and that makes sense. I'm multiplying something by something less than 1, right? If I have 1 pen here and I multiply by something greater than 1, let's just say 2. I multiply 1 by 2. How many do I have now? I have 2. Okay, I'm stretching that value. Well, here I have a pen, okay, and I need to multiply by 0.1 or 1/10. Okay, I'm going to take 1/10 of this pen. Ready? I'm just kidding. I don't know how to break this into 1/10. But it would be smaller, right? It's compressing. All right, and that makes sense. Okay, so what are our transformations? Well, we are going to have a reflection across the x-axis and vertical compression by a factor of 0.1, or you can say 1/10, because that's what it is. Okay. Next, all right, here I have a 1 over b value. That's 1 over b. 1 over, this is kind of the steps I take. Okay, what's 1 over b? Well, 1 over b is equal to negative 3. Okay, what's b then? Well, b is going to be the reciprocal of that, which is negative 1/3. All right, so just note that that is less than 0. So that means we are going to have a horizontal reflection, right? Or a y-axis reflection. And then also to the absolute value of negative 1/3. Hey, that is less than 1, right? So that means horizontal compression. All right, so what is our conclusion? We can say a reflection across the y-axis and a horizontal compression by a factor of 0.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333. All right, there you go. Whoop. Okay, now practice problems. Boom. Haha, there they are. Go ahead, pause the video. I want you to try these. Give these a go. All right, hopefully you paused it. Here is the answers. We have a k value of -2, so we're going down 2 units. Makes sense. The next one, we have an a value of -2. It's negative, so we have to reflect. Okay, did you get that one? Good job. And since it's bigger than, since the absolute value is bigger than 1, then we're going to stretch. I know it's negative, right? But since the absolute value is still bigger than 1, we're still going to stretch. All right, and then the last one, g of x equals 1 over x minus 6. That's an h value 6. We go to the right. Another set of practice problems. Please pause me. Did you actually pause me? And then go ahead and try these. Here are the solutions. Okay. So we have a 1 over b value that is 9. So you have to take the reciprocal. So it's 1/9. That's horizontal compression. All right. Example 2, 0.3 is an a value. That's going to have a vertical compression by a factor of 0.3. And last but not least, we have a 1 over b value that's negative 0.8. And this one might really throw you off. You're like, what the heck? Like, how did you get 5/4? Okay, so 1 over b, this is negative 0.8. Or, what if I said this? How would you say this? This is 8 in the tenths place. So isn't this 8 tenths? So then b is equal to negative 10 over 8, which if I reduce, we get negative 5/4. And you're like, come on, that's not fair. I know, but you guys are in accelerated math. You can do this. You like a challenge, right? All right. Okay. I think I have 2 more examples and then a practice problem, and then that is it. Okay, so here's what we're going to do. We're going to throw everything into one pot. I'm going to give you an a value. I am going to go ahead and give you an h value, and I am going to go ahead and give you a k value, and then we're going to go ahead and identify all the transformations. All right, so a value is equal to 3. All right, so I know that that's going to be stretch, right? Because it's bigger than 1. And I have an h value that is equal to positive 1. I know I'm going to the right 1 unit. And I have a k value, I think is positive 2. It is positive 2. So I'm going up 2 units, okay? And that is it, okay? So we will say a vertical stretch by a factor of 3 and a translation 1 unit right and 2 units up. Okay. All right. There is our answer. Next example. All right. Identify the transformations. So f of x equals 1 over x. Thus, g of x is equal to 1 over 2. Okay, there's a 1 over b value times x plus 3. Okay, there is my h value. And I have a k value. That is negative 1. Okay, so again, I make my little notes. 1 over b is equal to 2. Thus, b is equal to 2. That's going to be horizontal stretch. K value, which I'm not talking about right now. H value is negative 3. We're going to the left. And then K value is equal to negative 1. It's going down. All right, I know I'm lame. Okay, so we have a horizontal stretch by a factor of 2, comma, and a translation 3 units left. Schwarberg, what about the negative? Okay, you don't have to include the negative. The negative just tells you the direction, right? So how many units are you moving left? You're moving left 3. The left kind of tells you it's negative. Translation 3 units left and 1 unit down. Sweet. All right, last example. Okay, here I have an a value. That is negative 0.5. All right, I have an h value that's negative 1 and a k value that is negative 3. So let me see if I can, well, I'm going to practice good habits. Negative 0.5. Okay, it's negative, so we are going to have x-axis reflection, and this is vertical compression. All right, then we have an h value that's -1. So we're going to the left, to the left. Everything we own in a box to the left. Do you guys know Beyonce? Do we know Beyonce? This guy. Okay, so there is our answer. All right. What do we have? We have a x-axis reflection. A vertical compression. By a factor of 1/2. Hey, can I do that? Is that illegal? I will make it illegal. Okay, and you can use 0.5 if you don't like fractions. Fractions, scary. Okay, and translation. Boop, boop, boop. 1 unit left. And I feel like this is a run-on sentence, but it's not. I used a comma. I think this is right. I'll ask Middleton. And 3 units down. All right, hey, there you go. That's it. I have a practice problem for you. Here is, what? No practice problems? Is that just a duplicate? It's not a duplicate. All right, one more example. Actually, I'm gonna skip this one. It's the exact same. The exact same. Here's your practice problems. Go ahead, please pause the video. Give these a go. All right, hopefully you pause the video. Here is the solutions. All right, so nothing too crazy in this one. I would just say on the second example, I hope you picked up on the -3, which means that your B value is -1/3, right? You're gonna have horizontal compression by a factor of 1/3, along with that horizontal reflection because it's a negative. Everything else should be pretty straightforward. That's it for this lesson. I hope you learned something. I hope you enjoyed it. Catch you next time. Be safe, be easy, be healthy. Bye.